Hello everyone, welcome to my channel on model railroading. Today's video is about my scratch-built HO scale WAG-9 electric locomotive. WAG-9 is a 6000 horsepower 25 kV 3-phase AC electric locomotive which has been the mainstay for hauling freight trains on Indian Railways for over 2 decades. Over the years, the locomotive has undergone several upgrades and modifications to increase its tractive effort, horsepower and operation. The prototype I have modeled is the early version, which is characterized by the solid cow catcher at each end of the locomotive. My model build is mostly complete except for the decals and lettering that need to be applied. But I thought I'll give you a sneak peek into some of the highlights and details of the model. So let's jump right in. On the inside, the model has a die-cast chassis frame and a custom-built drivetrain with a dual flywheel Northwest Shortline 2032 D9 can motor. The Coco bogies are scratch-built including the gear mechanism and scaled to match the WAG-9's 3.7 meter bogie wheelbase. I've installed a LoCSound 4.0 sound decoder for the digital control of the locomotive. And also is a standard ESU 1.5 watt round speaker for the sound. The locomotive is wired to run by picking up power from the rails of the track or from a powered overhead catenary system through the 2 pantographs like a real electric locomotive. I have installed LEDs for the headlights and marker lights, which I will go over later on in this video. I added some extra weights to the chassis to bring the locomotive weight up to around 450 grams. This combined with the torque of the Northwest Shortline motor gives it some pretty decent hauling power. With that, let's put the shell on and go over some of the body details I have incorporated into the model. The model is built in HO scale and externally measures approximately 22.15 cm over the headstocks, 4.52 cm from the top of the rails to the cabin roof, and 3.52 cm wide at the widest part of the body. The model body is made primarily using modular styrene and ABS plastic with both commercially available and handmade brass and plastic detailing parts. Starting with the front of the locomotive, some of the details you can notice are prototypical window sill detail, scaled brass wire handrail, headlight and marker light moldings, MU receptacle, an etched brass walkway shaped as in the prototype with the underside support braces, scaled buffers, brake air lines with the ends painted silver, and of course, the solid cow catcher that is prototypical of the early version WAG-9. There is also a moving coupler cut lever bar for some added realism. On the side of the cabin, there is more window detail, cab door with metal door handles, scaled brass wire handrails on either side of the door, and an etched brass tread plate step below the door. The bogie frame is completely handmade and features the 2 sandboxes, etched brass tread plate steps, prototypical axle boxes with spring detail, secondary suspension damper, secondary suspension spring, safety chain, wheel set guides, primary suspension damper, and the brake air line. The only features I did not include are the brake pads and the brake rods, as I could not replicate them to my satisfaction. In the underbody section, there is the compressor, some piping and cable detail, main transformer, and the battery box, all detailed with some characteristic features. On the side of the body, you can see the 2 see-through grills as in the prototype, and the rear cabin, which is identical to the front cabin with similar details. On the roof, you have the 2 pantographs, the horn and emergency light above each cabin, the piston actuator that moves the pantographs up and down, the roof high voltage line supported by scaled ceramic insulators, replicas of the surge arresters, the main circuit breaker, potential transformer, the resistor harmonic filter box, and the see-through vents. The other side of the locomotive shell is a mirror image with the same detailing, so I will skip showing you that and move on to the lighting effects. For lighting, I have installed LEDs for headlights and marker lights that are controlled by the function buttons F0 and F12 on the LoCSound 4 decoder. The headlights are warm white LEDs, and there are two marker lights on each end, a set of white LEDs and a set of red LEDs that light up based on the locomotive direction. To demonstrate, I have the locomotive set in the forward direction, and pressing F0 turns on the front headlights. F0 can be toggled to turn the headlights on and off. Activating F12 turns on the marker lights. Since the locomotive direction is set to forward, the white marker lights turn on the front side, and simultaneously the red marker lights turn on the rear. If the direction is changed to reverse, F0 now turns on the rear headlight, and F12 turns on the white marker lights on the rear of the locomotive and the red marker lights on the front end, which now is the direction opposite to the locomotive movement. So let's put the locomotive on the tracks and listen to some of the sounds. The sound file is a collection of various sounds from different ESU projects for electric locomotives. The main sounds programmed to play are the blowers, fans, traction motor sound, compressor, air release sounds, and the brakes. I have programmed an actual recording of the high-pitched horn typical of WAG-9 and also included a faint brake squeal that plays when the locomotive just starts to move. This is to simulate what I have noticed in my rail fanning experience, where a faint brake squeal is heard when a train starts to move and the brake shoes have not fully disengaged from the wheels. So turn up the volume and let's take the locomotive for a spin. That's all folks, thanks for watching. I hope you enjoyed this short video demonstration and I hope to see you on future videos.